In this video, we're going to look at the multiplication of monomials. We'll be using the rules for exponents we talked about in an earlier video. And a monomial is simply a term that will have a product of variables. It could be one or two variables. It could be a constant. It's going to have a coefficient, numerical coefficient. So the first term here has a coefficient of -3. The variables are x, y, z, and the exponents on those are none, negative integers, 5, 3, 2. And the degree of the monomial is simply the sum of the exponents. So 5 plus 3 plus 2, that's 8, and 2 is 10. So the degree of the first monomial, the first term if you want, is 10. The second one has a variable x, z, exponent of 3 and 4, coefficient is 5. Add the two exponents, 3 and 4 is 7. So the second one has degree 7. A constant, a number, say like just a plain old 7, that's considered also a monomial. I can put an x there as long as I put a exponent of 0. I guess x to the 0 is 1. Something like 2x to the -4, or say 5xy 1/2. Those would not be monomials. The first one has an exponent that's negative. The second one has a fractional exponent. So those are not monomials. So on this one here then, you're just multiplying 2. And this is going to work whether you have 2 monomials or you have 3. You simply group the like terms together. So take the coefficients. Have -3 times 5. And then in the next one I look at the x's. So I have an x to the 5th, x to the 3rd. Grouping those together, then I'm going to group the y's together. There's only one y term. So leave it like that, and then the z's. And then we just follow the rules for exponents. Now for the first one here, first parentheses, those are just numbers, so let's multiply those out. -3 times a +5 is a -15. Got x to the 5th, x to the 3rd. So the rule is, bring down the base, add the exponents. 5 and 3 is 8. We only have one y term, so just bring it down, y to the 3rd. Then bring down the next one, z squared times z, bring down the base. Add the exponents, 2 and 4 is 6. And notice I don't really have to put a multiplication or a dot here for multiplication because it's understood to be a multiplication there. So this is the product of those two monomials. If they ask you for the degree of the monomial, you simply add the exponents. 8 and 3 is 11, and 6 is 17. Now, depending on what your teacher wants, you can just do it by inspection here and just say, well, I know I have to multiply the coefficients, so 5 times a -3 is -15. Just bring it down. And then we have an x to the 5th, we have an x to the 3rd. I know if the bases are the same, I add the exponents. 5 and 3 is 8. I get x to the 8. I only have one y term, so I just bring it down. Y to the 3rd. Again, z squared and z to the 4th. 2 and 4, 6. There you have it. Okay, the next one, again, same sort of thing. So now I'm just going to do it just by looking at this. You can group them together if it helps you, but it's just multiplying the coefficients of the two terms. So the first one has a coefficient of -7. The second one -2. So just say -7 times the -2. Both are negative. So negative times a negative is a positive. I get 14. And then I have an x to the 9th and an x to the 2nd. So over here, just bring down the x. Okay, the exponents on the x here and the x over here is 9 and 2, so it's going to be 11. Now I have a y to the 5th and a y to the 1st over here. Remember, if it doesn't have an exponent, it's understood to be a 1. So bring down the y. And then the y has exponents of 5 and 1. 5 and 1 would be 6. Then we have a z. Bring down the z. And then look at each parenthesis. Z here, again, doesn't have the exponent, so this is understood to be a 1. So it's 1 and 3 is 4. That's how you multiply monomials. Now you can take it a step further and deal with polynomials, which are expressions involving a sum difference of monomials. So you could have a polynomial of 2 terms, which is called a binomial. You could have a polynomial of 3 terms. And when I say 3 terms, we're talking about monomials. So 3 terms is called a trinomial. And then everything else is just called a polynomial. If it has more than 3 terms, you just call it a polynomial. Won't spend too much time with division, but basically it's the same sort of thing here. Let's just say I have these terms here, and I want to divide. So let's suppose we have -3. Okay, so suppose instead of multiplying these two monomials, they ask you to divide them. So I have on the numerator and -3x to the 5th, y to the 3rd, z squared divided by 5x to the 3rd, z to the 4th. So this is going to equal. Just like the multiplication, you do the coefficients first. So -3 divided by 5. 5 won't go into -3. So we just leave it. We just leave that as a -3 over 5. So that's going to stay. And let me just do it this way here. And then just look at this separately. X to the 5th over x to the 3rd. So if you were just doing this part here by itself, x to the 5th over x to the 3rd, you'd bring down your base, subtract the exponent. So it's 5 minus 3 would give me 2, so that would be a 2 there. And then y to the 3rd, there's no y over here to cancel, so this is just going to stay y to the 3rd. And then here we have z squared over z to the 4th. Now I could write the z over here and say, okay, z, and the power would be 2 minus 4. But that would give me a z to the -2. So I could leave the z to the -2 in the numerator. But generally on these types of problems, they're going to want you to write it, simplify your answer, or give your answer without negative exponents. So instead of leaving z to the -2 in the numerator, remember, if you have a negative exponent, switch it to the denominator. So instead of z to the -2 in the numerator, I put z to the +2 in the denominator. And this would be your answer. So in the numerator, I have a -3x squared, y to the 3rd. And the denominator, I would have a 5z to the 2nd. That's your simplified answer. Now with this one over here, just by inspection here, set it up the way I did over here, and just look at the like bases together here, and do it. Or your teacher lets you do it visually here. You have a -7 or a -2. Well, the negatives cancel out, so that's going to come out positive. And since I can't reduce the expression 7 over 2, I just leave it like that. And then I have a x to the 9th in the numerator, x to the 2nd in the denominator, so the x will go on top, because I subtract the 2 from the 9. That's x to the 9th over x to the 2nd would give me a +7 as an exponent. And then I've got a y to the 5th in the numerator, y to the 1st in the denominator, bring down the y, and then the exponent on the y in the second monomial is 1. 1 from 5 is 4. So I put that over here. And then in the numerator, then I would have a z, and the denominator I have a z to the 3rd. So if I subtract the exponents, bring down the base, subtract the exponents, in the numerator I'd have a z to the -2, because that's 1, subtract 3, -2. But again, instead of leaving the z to the -2 on top, I bring it to the bottom and just change the denominator and just change that to a positive. So this is a 1 here, 1 subtract 3 is -2, bring it down, it becomes that. So I got 7/2 x to the 3rd, y to the 4th, over z over the product 2z squared. Now we carry this process over to polynomials, multiplying a monomial by a binomial, binomial times a trinomial, and so forth. You're still going to be using the rules for exponents. Thanks for watching. We'll see you next time.